I think from this point on, we have to decide what we call quadrupeds.
Yes.
Just dogs, I guess. Like you worked on dogs, robot dogs.
Robot dogs, yes, exactly.
And both of you are postdocs in robot dog research. I mean, that's a bit crazy. I mean, is this like, when you talk to like normal civilians outside of the academia, when you introduce yourself, like, oh, I do research on robot dogs, does it like get you a weird reply, maybe a sparkle in people's eyes?
Yeah, the reaction is, some people are, oh yeah, that's cool. Some people are just, oh, taking our job, right?
Oh yeah? Yeah, you get that a lot. I think if you mention robotics,
that's
anyone.
true. Like, it's one of the main fears, yeah.
I think it's becoming okay now. I feel maybe 10 years ago, people were more focused on that. Now you have robots everywhere and it's just normal and people are not that afraid anymore, I feel.
And out of all robotics, I mean, robot dogs are the most acceptable, right? I feel like people have seen it on YouTube. People have an understanding. It's a bit cute. It has a cute effect on it. So
they're both. Some people think, oh, that's really cute. And some people are just afraid because it's a robot that mimics something that is living. So you have people, oh, that's very frightening. Like if you look at the Black Mirror episode with Quadruped Robot killing everybody.
I didn't like Black Mirror at all. I watched a bit, but we'll get back to that. But do you ever like, sometimes I look back in my relatively shorter career than yours and be like, I build robots, man. Like always, you guys, okay, for people who don't know, like you have a 4-year master's degree after you finish high school. Then you decide to do a doctorate degree, which is like 4 to 5 years. In some places it's less, like in the UK you can do a 3-year. In China I think it's like 5+ years. In America it's also very long.
Yeah, it can be up to 7 years, I think.
Up to, let's say, 5 to 7 years of hardcore, bleeding edge research. And after that, in between the doctorate degree and being a professor in robotics, there is the postdoc. And that's what you guys are. Like, you are postdocs. Closest thing to a professor in robot dogs. That is not a professor in robot dogs. Like, do you ever look back and like say, no way, like I'm different?
Well, it is quite crazy, yeah. If you think about it in that way, like after you said it, like like it is cool, but like. When you're working on it, I feel like, at least in my case, I was surrounded by people that were doing the same job. So it became normal after a while. Like, I don't know, to me now it doesn't sound like I'm doing anything crazy.
What about you, Mathieu?
Yeah. It's just when you go on the path, so when you do a PhD, you still have a salary. So it's like a first job. And then postdoc is a bit better job, but yeah, it's doesn't feel like you are doing just studying for 10 years. It's just you are working on robotics. It's just a different kind that you have in industry. It's more like research, but still a job. You get a salary. You do play with robots, so. Really nice.
Did you feel like you were pushed in the direction to work with robot dogs specifically, instead of maybe a humanoid or maybe like a robot arm? Did you feel like a connection with did you feel like it was cooler, that's why you chose it, or was it just a chance?
I think in my case it was mostly chance. Like, what I was really interested in was the idea of kind of like giving life to objects, like taking a piece of metal and like making it move. That was all I cared about. And then there were other factors that weren't necessarily related to humanoids or quadrupeds, but more about like the institution where you want to do your PhD. So like I chose that, and I decided that I wanted to make my PhD at the Italian Institute of Technology, and in that institute, there were two options: either the quadruped or the humanoid. So I applied for both, but I did prefer the quadruped because that specific quadruped was hydraulic, and because I came from a mechanical engineering background, I was more interested in that compared to electric robots. So it just happened, but I wouldn't say I had a particular connection to quadrupeds. Now I do because I've been working on it for like 7 years, but like in the beginning it was just a chance.
And you, Mathieu?
So for me, I started to work in a research lab at the end of my master. So the lab was actually just next to my school, my engineering school, and I did the internship, like the last part of the master, the internship there. And yeah, like when you look, it was humanoid robot, not quadruped robot actually. And yeah, that's like, I feel it's the top of, like when you talk about robot and you think about like what would be the most advanced robot, humanoid and quadruped, I think it's right what you have in mind. So yeah, that was a very good experience. I went there, did my internship, then engineer, then PhD, stayed there almost 5 years. And then when you work on humanoid, it's all the locomotion, it's the same principle, it's legged robotics. So humanoid or quadruped robot, it's very similar. And yeah, I just applied to Oxford, and I was actually very lucky because the project was managed. I was hired on a European project, and it was run by my PhD supervisor. So like the topic of the project was right in what I did during my PhD. So it was like when they published the hiring thing, the description of the job was exactly my profile. So it wasn't really that difficult for me to get the job, like just perfect fit. So yeah, a lot of luck.
Do you feel like Romeo as well, where there was some sort of magic behind it, like putting life into these? Do you guys, maybe having spent almost decade in top echelon of dog robots and human robot research, that maybe the magic wears off? But did you have that in the beginning where you were like, this is almost a living thing that I'm building? Like it walks, it trips, when it falls, it's so naturalistic looking. Like, did you have that magic as well?
Yeah, I think so. Like, I remember even when I was like just a child, I was already amazed by robots. Like, I remember watching on the TV like the French robotic cup, and I was, wow, that's so amazing. And yeah, when you start working on a humanoid robot and you see it move, like everybody is amazed by that. I guess after some time you just see more the machine than a living thing. But yeah, when you try to step back and look at what you are working on, you are, oh yeah, that's awesome.
You are listening to the XOR.
Human conversations at the frontier of technology.
This is the XOR.
The XOR.
The XOR.
The XOR.
The XOR.
XOR.
Both you spent quite some time together at the Oxford Robotics Lab, right? Like, what will be your specialties, right? Like, describe in very few words what engineering you did while doing your postdocs.
Maybe I can start.
Yeah,
well, I mean, basically, I would say my skill is the capability of like turning the desired action that you want the robot to achieve into commands for the motor. So it's basically about designing the software on the robot that will transform like the desired motion of the robot in a given direction into a current or a torque command to a motor, and that often includes also considering cameras that that can, let's say, show what's the environment about the robot. So I would.
Was it like? Would you say it was more taking the environment and the desired goal of walking or trotting or running into actual like electrical commands to the motors, right?
Yeah. Yes. Exactly.
What field is that? Perception? Was that more perception or control?
Well, I would call it perception when you include what we call exteroceptive sensors like cameras and lidars, because that's what gives the robot the ability to perceive the world around him. Otherwise, when you just use like the onboard sensors on the robot, that's called control, as far as I know.
Yeah, control or planning.
Motion planning, yeah.
Which part you are working on.
What's your specialty?
Same control on the robot. So maybe to go a bit more on the detail of the work. It's mainly trying to study the physics, and then from that trying to build algorithm to make the robot work, and then code that. Just mainly C++, put that on the robot and try to make it work. So yeah, it's a lot. We are using a lot of optimization algorithm just to simplify things. So instead of trying to define exactly the solution, you will just define a problem where the solution will be the robot walking, and then you let the machine just solve the problem. So like just a simple example, if I want the hand to grab the cap, I can design an algorithm where my objective is to minimize the distance between the hand and the cap. And then I let just the machine compute all the parameters and try to come up with the solution itself.
Yeah, I guess the goal is to make sure you don't have to, we say, hard code the motion, but you actually come up with something general that can work in multiple solutions, in multiple cases, even if the cap is not exactly here, but it's like 5 centimeters to the right, then you want the robot to be able to adapt to that sort of, let's say, unexpected event. So I think that's what the modern research is focusing on. Otherwise, if you just write in the software every single motion, that falls into the traditional industrial robotics that has been already around for decades, I would say.
Yeah, and one thing also that we did is trying to mix normal control algorithm with machine learning. Machine learning is very similar to what I was saying. It's just that instead of trying to solve the problem online, you just do a lot of simulation and try to find the complex function to make the robot work. But it's still based on optimization. You will still try to minimize something. It can be like if you do reinforcement learning, your task is to maybe work at 1 meter per second, something like this, and it will try to change all the parameters in the neural network to try to minimize this error and try to make the robot go at the velocity you ask.
That's very interesting, because when I had my first experience with the humanoid robots, that was my first thing that was like, can we not do just goal-oriented programming? Can we not just say, like pick up this box, and you know, if you slip, pick it up again. Just like that's your goal. And then I realized like, no, that's like the edge of like what's possible. That's like the edge of, you know, AI as we know it, to have goal-oriented programming, to just say, you know, here is a problem, let the robot fix it, and then hypothetically like learn on that, so then the next problem it can just, you know, immediately execute, just like children do, right? But then I was like, it's like, can we not do that? Like, do I have to write everything, like every edge case? And they were like, yeah, you do.
Yes,
you do. Like, yeah,
that's exactly what you have to do.
Like at an early level, like at university, it's like, you know, put your arm here in this exact coordinate, and then like maybe move in this direction with this velocity, with this much force. And if the box that you're carrying slips out of your hand, you're screwed. Like, but then, yeah, like, do you think that will it all be like, that's where we're going? That's really is the goal of robotics, to software, maybe especially, like moving in the direction where you just define goals, like define super high level ideas, like survive, or, you know, capture the flag or whatever. And then the entire complex space of possible solutions, possible actions is just, you know, it's none of your problem anymore.
Yeah, I think like currently one issue is that you don't have robot everywhere, just because it's difficult to program them, to make them do what you want. But as soon as you can just say, oh, clean the kitchen, and the robot is able to do it, then that will simplify a lot of things for the users, but also maybe for like industries. Like currently, if you have to say, oh, the robot need to go here, then here, then here, it's a lot of work. While if you can just say, oh, screw all the screws there, then simplify a lot, and you can reduce the time to set up a factory or something like this.
Do you think that's at all possible? Like, how far are we from that? Like, or have you seen something remotely close to that, where it's...
Yeah, I think there is a paper from Google where they just give, I think it's just a voice thing, like someone say, oh, I dropped my can of soda, and the robot then need to go take a sponge to clean, and then bring another can to the person. And yeah, I think in the paper they say the robot is able to do like 80% of the time to do the right task, and then achieve to do the task like maybe 70%, something like this. But yeah, it's like I think a big improvement is also like now you can have natural language stuff, like all the don't remember the name of the... Is it Dolly? No, Dolly is for drawing.
Dolly's for pictures.
Like
I don't know.
There's a
AI
thing that came out
can...
recently called Whisper. I don't know if you know. That was like the latest and the greatest, and it's always open source, and it's crazy.
Oh, is it? I should try it.
But yeah, basically you're saying like with the introduction of like open source, like machine learning models, voice models.
Now you can easily just identify what the person is saying. You have neural networks now that can understand text and trying to understand the meaning of some text and deduce some action from that. So yeah, it's I think AI, like it's gonna be the next big thing. Like I'm so amazed by all the thing like Dolly. I like 2 weeks ago, I think I downloaded the Stable Diffusion. It's the open source one. Just playing on my computer, trying to generate something. I think it's the next big thing that can just explode.
Yeah, I've spent a lot of time on these image generations. I think I've run out of, in Stable Diffusion, I ran out of like tokens. Like that's how many times I tried.
No, Stable Diffusion is open source, so you can download.
Well, yeah, I think the web thing. Maybe if you download the Python library, you can do as many times. Do you feel like, obviously, like the intersection of robotics and AI is definitely like the AI is really the key to get this mass market. But as engineers, like you guys are, I guess, engineers going into software, right? Like you yourselves, do you view yourself as like machine learning engineers? Probably not, right? Do you feel like you're missing out on where the fun is, basically?
Well, maybe partially yes. Like I don't have a machine learning background, but yeah, I do agree that like that's where the future is, and like if I want to keep up with like the technology, I do have to work on that too. It's if you have experience with a humanoid or a quadruped, you just see how obvious that it is, that there are simply too many details, that too many things you have to take care of, and you can't simply engineer them all. And machine learning kind of offers that help you need, right? Kind of offers the possibility to like gather all the parameters in one goal, like you were saying before, right? You just, instead of having to tune 20 different parameters, you just give a goal to the robot, and that is so incredibly helpful and allows you to focus on like the other tasks, right? Like making sure that the quadruped cannot just do one task, but like can do can be versatile, it can do a lot of things.
Do you feel like there is we'll take a couple of steps back, but the field of robotics is enormous, right? And there's not enough life to like really learn all these skills. But is like control systems really underrated? Like it's equally as hard, and you can do a PhD in postdocs and control systems and miss out on maybe the hype of the current AI and machine learning world and reinforcement learning that maybe borders on control. But what do you think? Like, do you think it's if you had a really, really experienced control systems engineer, you might be overshadowed by someone maybe, and also, I mean, the salary wise, right now it's just not even comparable.
There's
right?
a big gap. Well, personally, I think that they're both very important skills to have, and like if you only are a machine learning engineer, you might end up and you know nothing about control. You might end up doing things that are probably like an overkill. Like they could be like more complex than they could be if you were following classical control theory. So I mean, the way I see is that both control theory and machine learning, they're tools, and you need to know when it's best to use them without having like any prejudice, like any preference. Like I prefer machine learning or control. You just have to know when they work the best.
But in the end, just do machine learning, right?
Well, I personally like control because you need to have a very good understanding of the physics behind it, like Mathieu was saying. So, that's just a personal preference. Like I'm very fascinated by the fact that with maths you can describe what happens around us. And I don't know, using control theory, it's just like such an incredibly powerful tool that like I don't think you should miss out. Like if you just know machine learning, you will not necessarily capture this I don't know, the power of control theory, I think.
What about you, Mathieu?
Yeah, I think there is advantage and disadvantage of machine learning. So I still think control is something really useful, just because sometimes you want to do something easy and you don't want to spend just hours training a neural network to do it. And if you can do just simple control, it will be always useful. So I see like two things that complement each other, I would think. Just for simple stuff, control is very good. I feel like mainly machine learning is when things get hard, like making a robot work. It's fine. You can do it with control. The issue is always like, oh, but what to do if you trip on something? What's the motion? How do you detect that? That's a lot of engineering. And if you do some machine learning, you can just have example in simulation of that. You train for a few hours, maybe a few days, and then you have the robot that just move the leg to avoid the collision or do a reaction to react to the collision. And that's much easier than just trying to program yourself. Oh, when you trip at this time, maybe change the foot position.
Yeah, we've definitely seen a lot of that now.
Yeah. So yeah, I think we still need both, just because also like machine learning, you are never sure exactly what the robot can do, and sometimes maybe for safety you want to be sure that like if you ask the robot to not move, it won't move at all. And if you just have some control part, you can really design as you want, really control the part you want to have, really enforce control on them.
These are good answers. I feel like I'm neither. I feel like I'm not. I would say I wouldn't. I have a like external observer opinion on this.
Yeah.
Like I'm not like
You don't feel involved in
in either
conversation,
like
yeah.
advanced control or machine learning. So I don't know. It's interesting to see people's. Like I think definitely there's an old school versus new school.
Yeah, it's a controversial topic.
Yeah,
always opinions.
Well, this is why
about that.
this why XOR exists. We have to discuss
we
controversial topics.
like controversial topics. Yeah,
How would you say? Okay, let's say there's a young starstruck engineer, and he is he has a lot like the open field of he hasn't yet made the choices. Like, what would you say? Would you say, okay, learn your basics, learn control for a couple of years, and then once you've cut your teeth in control, like go into something else. So, like, I think from, let's say, the control systems lead would say actually software is really important, because he is really adamant that a lot of the problems are really a software design problem, and then on top of that there is this science behind it. But in robotic, so what would you think? Let's say let's hear your opinion on just like what would you maybe do differently, or like an advice for a young roboticist starting out. What's the journey for him? What would you say?
It's a difficult question. I would say if you really want to work on robots, maybe starting with control, or could be a bit better. Just because when you do purely machine learning, you have a lot of different field. But it's not necessarily robotics, because like when you do like protein folding or natural language or image generation, all those things are machine learning, but it's not related to robotics. So I guess it depends on your interest. Are you more interested into AI machine learning, or you want really to work on a robot? I think if you want to really focus on robots, you can still do some reinforcement learning, do some machine learning, but you will probably need to know control quite well to be able to do anything.
Like now when you mention it that way as well, when I don't know many other applications of control systems engineering other than like motor control. So like if you do machine learning and then sometime decide that there are so many other opportunities that you want to go into audio synthesis or whatever, you can with machine learning, but with control you're really limiting your choices, aren't you? What do you think? I guess
Well, there are
you
a
would
lot
have to
of-
answer the previous question of where do you think the people should start?
Well, I agree with what Mathieu said. I mean, it's a question software versus hardware. Like, if you purely want to focus on software, then I think that's where machine learning achieves its best. So you could probably focus on machine learning from the very beginning of your studies and don't worry about control. But if your goal is actually like making real life objects move in our everyday life, then yes, then machine learning is still important, but becomes like as important as other subjects like control and mechanical engineering. I feel like a good software background is always important. So probably I feel like, starting with a bachelor in computer science, it's probably a safe choice. And then in your master, you can decide when you have, clearer ideas, you can decide whether you want to know more about control or just go straight into machine learning. So probably if I were to go back, that's what I would do.
Can't go wrong with a computer science degree, right? Like software, learn software if anything. Math and computer science.
Yeah.
And then you'll decide. And then if you're going into more math, there'll be control systems. And if you go more into computer science, it'll be machine learning. That's like obviously the hyper generalized and incorrect. But yeah.
Yeah, it gives you like a few years to kind of postpone like the question of what you want to specialize in. You can just like create a solid background in software and then decide later. I feel like that is a safe option. Yeah, I don't remember what else you.
It was just well, the question was I think the general notion is that what's the optimum for best results? Like, what do you really have to learn? You have such a limited time to get good at something in robotics, so you have to choose wisely. And the question is always, well, it depends on what you like. But a lot of people don't know. Like, a lot of people don't even know what they don't know. So they end up by chance falling into a certain field, and then they get good at it. And then, over time, they work in teams that complement their skills. But it doesn't have to be like that. It doesn't, like, maybe in hindsight, some people will not regret their choices, but be like, oh, if only, like, that decision changed my, like, entire career. Or, like, some people, let's say, well, my professor told me to do analog electronics. And, that proved to be a wrong choice in maybe in early 2000s analog. Maybe we come full circle and analog electronics come back.
Maybe we'll come back and it will be.
But basically, like small decisions in your early years at university, like really do decide what you work on, like for the large chunk of your life and like professional career. So if you were to go back and say, at least give people a notion of this is this and this is that. Like this is like give them an overview and like show them the horizon of what's possible with this. I think I wanted that maybe when I was, but all the career advisors at any academic institution are just completely clueless. So I guess
they also don't know exactly what.
Like I mean, if you're super curious, you'll listen to this podcast and maybe have hopefully just a slightly better understanding of what's what.
Yeah, I think that question is not just about like what subject you want to study during your university degree, but also in which university, in which institution, because that can expose you to so many different things. I feel like if you are in a big university that offers, for example, a lot of internships during your studies, that will expose you to to other subjects that are maybe not what you're studying, and then you're still on time to change your career path. So probably that's even more important than choosing between electronics and software engineering, right?
I think the good thing about machine learning is that you can do it very easily. You can find already a lot of stuff on just GitHub, on internet. You can already have some, like you have simulator to simulate things. You can get them for free. Just download TensorFlow or PyTorch and try to run some algorithm. And like I think NVIDIA has a free simulator with some algorithm to just make a quadruped robot walk, doing some reinforcement learning. So I think machine learning is something you can easily try to get something with just a computer. If you have a good computer or even just a laptop, should be all right. Like you let it run for 2 hours, you should be able to get something. So I think compared to robotics, machine learning, you can already do.
Yeah, the barrier to
something.
entry with control is probably even higher than machine learning. So
Yeah, so for control you can find simulator and try to play. Like if you download ROS, you can already play with some robots. But I would say it's more difficult to take on. I feel like usually machine learning, it's when you look at the code, it's not much. It's few Python file, and you already have tons of stuff that are code in PyTorch, and you just need to define the size of your network, and that's it. And so I think it's quite easy to pick up and play a bit. I think probably it's very hard to master it. Just know, because you have probably hundreds of parameters to tune, but to at least start to have a sense of something, how it's working, you can probably do it on yourself, on your own time.
yeah, good points overall. I think you Romeo, you mentioned depending on the institution. I think that's actually like super crucial. But you went to IIT, which is, I mean,
Yes.
IIT and Oxford University are like top, one of the best in Europe
Yeah,
for
in
robotics.
Europe, they're definitely good. ones for
I mean, my
robotics.
professor used to go to IIT for a bit. So definitely it's like very well known. Can you give like, let's say, do you have, let's say, a simple model of universities across maybe Europe or US and say, well, this would be specialized in that? We'll talk about, I think we'll talk about Oxford Robotics Group like a bit in depth.
Yep.
But what would you say the overall landscape of university? Do you have an idea? Can you say it like that?
Well, I mean, yes. I mean, I have it now after quite a few years of experience. I didn't have such a clear idea when, I had to take my own decisions when I, was at the end of my master and I had to decide what I wanted to do next. But now I see it, even more clearly, that unfortunately sometimes even just the name of the place where you work affects your chances, the exposure of your work. For example, the same paper that you publish in a very unknown university will probably not be read by anyone. And the same paper published in the biggest university in Europe will be suddenly it will appear on the LinkedIn profile of thousands of people, and they will all read it and cite it later. Exactly the same paper, right? So unfortunately that does matter. So I mean, I think anyone who wants to decide where to do his PhD should really first of all decide which subjects you want to work on, and then find the professors that work on that topic and possibly go and talk to the best of them, those who work in the best universities. It's kind of sad, but I think it's true that it helps.
What was your experience like at Oxford Robotics, like group? Like, what was your, like, what was the good and the bad? Like, what could you say about your time at Oxford doing postdocs?
The good is probably having mainly at the end, like we had a lot of robots, like Animal B, Animal C, A1, had Ghost Vision 60, and at the end they even bought
Spot.
yeah. So yeah, a lot of robot, because got a lot of money. Also we had engineers to work on the robot, so if a robot breaks, you have people to help to fix it. So that was really nice. Also, like a lot of partnership with some other universities, so you can bring the robot somewhere, try, like we went to the fire college, so it's where the firemen train to extinguish some fire, and we just had the robot doing some tests there, walking around just a fake factory and something like this. So yeah, I think that's the kind of thing that is really good, because Oxford is a good university, so you can get a lot of money, and then that allow you to properly do your research. In Toulouse, it was much more difficult. It was like one humanoid robot. It was a Japanese one, so if something breaks, sometimes we had to wait like 4 months for someone from Japan to come to fix the robot. So we were very careful. A friend of mine was quite pissed during his PhD because he couldn't do his research because it was a bit too risky. Could break a motor or something like this, and when you break the robot, that means you have like 3 other PhD students that can't do their tests for their own research. So having a lot of robots in Oxford was really nice. You're less afraid to break it. I shouldn't tell that.
Yeah. Yeah, no, that's true. I mean, you always have to, take all the precautions, make sure you're not gonna break any robot, but
Yeah, I guess
things happen.
definitely having also, I mean, a lot of funding to get the hardware in the first place, but also the team infrastructure that lets you really get on with your work, that like there are people dedicated to fixing issues at those places, right?
I think there needs to be a culture of trying to push for things that are new, and for a culture to accept some risks, right? So yeah, like you said, you need to have people around you that encourage you to try, and other people who will help you fix the robot if it breaks. So robotics, it's not something you can do on your own. It's just like such a complicated.
Would you say bigger teams, like bigger labs, tend to lead to better like if it's a community of roboticists in a lab, you achieve more, right?
If it's a group that works as a team, yes, I think that's obviously not always the case. You can always have like a lot of people that don't work as a team, and but in general, yes, I agree with that having a lot of people helps.
It helps also to get traction, because if you are in a group that publish, if you are just a group of 4 researchers or something like this, and you publish 1 paper a year, you're never gonna get traction. If you have 25 person and you publish, I don't know, 30 paper a year, then people will, I remember the name of this university. They are doing a lot of stuff. So help you to get more traction and more citation probably on your paper.
And it's also the the brainstorm that it generates, right? Like having many people, it means like talking a lot and like challenging the other people's ideas. So it's just more stimulating, right? I think that was actually probably my main kind of principle, like when I was choosing where to go. Like I always wanted to be in a place that's stimulating, right? So if you go in a small group made of 2 or 3 people, the amount of ideas, it's gonna be limited, I feel like.
So you would say like look for a good team, like look for a community of engineers within a university. So then that's fair enough. I think I would definitely agree with that. Like one-man armies don't really work in that. It's impossible, right? And
it's a kind of lost fight. Like sometimes you have geniuses who are incredible researchers, but like they work alone or in a very small team, and they will not get all the exposure that they deserve.
What would you say was the bad then? Let's talk about the negatives. This is your time to really talk. Say your piece.
Take it all out.
I think
I'll bleep everything out.
In Oxford, it's because it's a good university and they hire the best one and they take the best student. When you get in, they expect you to work like crazy because they say, okay, we hire you because you're good, but you kind of need to work then to kind of deserve your position. So you have a lot of pressure to publish, to work a lot. I'm not just talking about our team. I think it's something quite general in the whole university because they want to be the best and there is a lot of competition. Then you have a lot of pressure to keep publishing and trying to. So yeah, you can spend night in the lab, weekends in the lab. People won't be shocked.
Right? Like, I mean, is that really a negative? That's really understandable. I mean, if you are at a top institution, they're going to squeeze the energy out of you. But would you say that's a really strong negative like that?
It can be, depend on the behavior of the researcher. But some researcher can be really tough and limit, not normal. Like they can be a bit crazy. Maybe to rephrase that, it's like you're by being pushed so hard, the eventual outcome is actually less of what you could have achieved because you're just exhausted. Would that be true? No? Probably no.
But how is that a negative then? Like you're just tired all the time.
It's still a job. You don't have to spend your whole life at your job. You can have other activity outside.
All right, Mathieu is just lazy. What about you?
No, well, I agree with Mathieu. I mean, I think that working hard is fair enough. I think when you're starting your career, that's what you have to do. So you will end up working on weekends. I mean, that's acceptable. I think you don't want to do it for all your career, but at the beginning, I think it's fine as long as it doesn't affect your mental health. So that's obviously the boundary, right? Maybe a byproduct of that, I would say, that I found in Oxford is that people don't tend to work as a team as much as I would have liked because, like Mathieu said, like they literally the best from all over the world. They're so ambitious and they don't want to run into the risk of having their ideas stolen, for example, from someone else, right? So instead of having a nice, collaboration culture where one person helps someone else on one paper and then the other person, helps back, often the work is very individualistic, I would say. So,
it's something that was mentioned in the previous podcast as well, that some of the worst times you can have in the lab is when... it's me for myself. Like, what's the right English word for it? Everyone for themselves, basically. And like your success limits other people's success, and they see it the same. So it's a very toxic culture, and then no one wins, basically.
Exactly. And it's not just specific of Oxford. It happens in probably like all the best institutions that attack the most ambitious people. I think I feel like it's something that goes together with people's ambition of achieving results and making sure that everyone sees that it's an individual result. It's not the result of a teamwork. So,
do you think that's how robotics is meant to progress, with more open source stuff, like more collaboration is really that's like the only way for it to become a mainstream thing? Or do you think robotics has like a problem that is really stopping it from being the top industry? I mean, it is for manufacturing and heavy industries, but let's say mobile robotics is not yet that thing that it was promised maybe in the 70s with the humanoids and stuff. Do you think there is like some really key problem that we're not tackling?
Well, I mean, the first thing that I can think of is not necessarily about software, about open or closed source, but it's about the hardware, obviously, because the robotics, as I intended, it always includes some sort of hardware of moving parts, and the problem I see is the lack of lack of like conventions about like the let's say the integration between the hardware and the software. Like I think in order to achieve another breakthrough in robotics, we should all agree on like more interfaces between hardware and software, and instead of always over and over again coming up with custom solutions, I feel like that could be maybe a big thing we're missing.
Fair enough. Do you have an opinion on Mathieu?
I think it's probably reliability. Like a moving robot can wear quite easily compared to something like just a washing machine that is not moving. Like your car, you need to go quite often to somewhere to fix some part. So I think there is maybe an issue there where a robot is quite expensive and you will have to fix it quite often. So for normal people, it's maybe a bit too much. But you still see robot many places now. Like it's maybe not the kind of robot like humanoid robot, but like you have vacuum cleaner and things like this that start to populate the underground or your home, thing like this, and those machines are already quite nice. Like they can map your whole flat and do the cleaning. And even now, like you have the vacuum cleaner and the wet cleaner at the same time.
I think I agree. That's like an underrated point. That, as we said before, to do a lot of research and to try things, you need to try things. A lot of the time, when you try things, you'll break the actual robot, and it's so expensive that it's not going to be allowed. And the barrier of mistakes, the cost of mistakes is so high that people don't do it. And that's probably like even the most expensive, 200,000 to 500,000 pound humanoid robots, they're so fragile that you treat them like you barely do any research on them, right? So
Yeah, one issue with humanoid robot is like you have 100 kilos, that is 1 meter 80. If it falls flat, you will break everything. So it's very dangerous to move those kind of machines just because they are not bolted to the ground. So they can easily just, if you lose the balance, then you fall flat on the ground and you will probably break an arm or something. So yeah, you need to have a proper control before you can imagine having that somewhere.
All right. No, I think okay. Let's put this into a coherent thought, right? Because you said like some of the most important things in choosing an academia to work for is the team. Like it's super important that robotics such a vast requires such vast areas of expertise, and requires a cohesive team, but not just in academia. I think definitely in industry that's also important. Like robots are built by teams more than any other product in any other industry, right?
Yeah.
So like what do you think teams get right and wrong in robotics? Like we talked about this for sure in the previous podcast, but what in your opinion is like this happens a lot and this needs to stop? Like this is a common pitfall in robotics teams. I think I would get let's say I would start in the common misconception I think in hiring is hiring like specialists can work, but people tend to like, oh, robotics will need one mechanical, one electrical, one software. They tend to be so structured, and that definitely leads to either a lot of handoff between like specialists.
Yep.
Because that's like they have very narrow focus. So then neither one of them is a robotics engineer. So like hiring robotics engineers who are like, let's say, mixed martial artists, like right there, you definitely need in some teams complementing your teams with very senior robotics engineers that can pull these or whatever systems or whatever, like the pull everyone together. But if you tend to, I've seen that a lot when maybe someone less, they tend to simplify it too much, where it's like, well, we'll get one software guy, one electrical guy, one mechanical.
Yeah, but then those three guys, they don't necessarily speak the same language, right? So they don't.
They design three products basically. They design a product each, and then some poor manager has to like pull it together into a robot.
Exactly.
And I think that's a very common issue that maybe with time will get better, because there'll be more people who are started off as roboticists and they have complete experience off the bat. Whether maybe like in early 90s there was no such thing. It was like, I do electrical engineering and that's it. Maybe, I don't know. What do you think? Like that's my I think 2 cents. What do you think teams get wrong in robotics, like in management, in day-to-day activity?
Yeah, no, that's definitely a good point. Maybe the other point I can think of is about planning the activities, and even when you hire like specialists who definitely know what they do in their own niche field, I think it's still important that you have someone like overseeing the whole projects and like agreeing on like the next steps together, so that the people don't, let's say, diverge and let's say focus on what they think it's the most urgent thing to work on. That's something that doesn't really exist in the university as far as I've seen, and in the industry I think people try to do it, but it's really hard. It's really hard to keep the specialists from diverging on their own path. So yeah, I see a big challenge in the management. Like you need managers who need to understand the business and understand a bit of electronics, mechanics, computer science, be able to talk to all of them and be able to
Basically asking for a genius, like, right?
Yeah,
like it's way too much to ask,
I know,
right?
it's a lot. It's a lot. I don't know exactly how you can get that. Like, it's almost like, you would need maybe such a long training path, right? It's almost like surgeons, right?
Like, this guy is not under 30. Like,
Exactly.
it's impossible.
Yeah,
like, this guy is like mid 40s probably, with all the experience that he needs to be, and he needs to be a very special, like, individual on a personal level, right?
Yeah, we need more of those people, unfortunately. I know it's hard to find them, but like it's like surgeons, right? Like, when do you become a full, like, independent surgeon that can operate on your own? Like, you're not younger than 40 when you can do that on your own. And I feel like we need something similar, like a similar path for like full robotics engineers.
Maybe if there was like in time there'll be a robotics manager degree, or it's just
maybe yes,
it exists. I think in UCL there's a management science degree which is becoming very popular, and it's quite serious and it's intense. But do you have something to add on the team pitfalls?
Yes, I agree a bit with what Romeo said, but I think it's not the only solution to have someone that knows everything. I think usually the issue is that there is not enough communication between people, and I don't think like one solution can be to have a manager that knows everything very well, that can like enforce this kind of communication. But I think it's more like you don't need someone that knows everything. You can just trying to enforce more reliability, the communication between people. Like when someone in mechanic designs something, it shouldn't be like, oh, he designed and then start to build and things like this. It should go through the whole team to know, like, okay, there is this mechanical design, what kind of electronic we need for that, what kind of control we need for that. And yeah, having people working together. And more general, I think it's the same thing also in academia. You can have people working on their own project, but one thing that I loved when in Toulouse, in my lab during my PhD, is that my supervisor kind of at some point designed a project like called Loco 3D, and he was like, okay, so we're gonna have a pipeline about planning the footstep, then doing some motion, and you can see like, oh, this is my part. So it makes you feel more like a team as soon as you have like a big picture of where everybody is and trying to understand a bit more like, oh, my output should be this, and if I'm missing this part, then the next person in the pipeline won't be able to do his research just because I need to add also, I don't know, like the footstep position for the next one to be able to design the center of mass trajectory. So yeah, I think you need just to make sure there is good communication. I think the issue is that often you have a lot of smart people, but they don't really like to, they have some idea and they want to work on it. Maybe it's not ideal, it does a bit the job, but they really want to work on this, and they think, oh, this is a very smart way of doing it, and don't really listen to the requirement or to the other teammate. They are just, everybody's on his own desk and don't really think, oh yeah, it's gonna once it's ready, it's gonna work. And then you put that, and then oh no, it's not.
Then you realize
what we
something
need,
is
yeah.
missing. Yeah.
Do you have a good example of that? Can we? I don't know if you know on YouTube they do tier list videos, where you have like, let's say, S tier, A, B, C to D of anything, and it's common
Right.
to do like C tier TV shows, and they'll rank like S tier, which is like, you know, the best, and
Oh, yeah.
the worst, and they get a lot of traction. There's a very fun video to make, but if we were to make like this, maybe, wow, I think it would be a good like YouTube thing to do like a rank robots like from S tier to lowest tier, like maybe like the worst robots you had to experience with. But what if like in teams, like can you come up, are there any like famous teams apart from challenges, maybe university teams, company teams that have just like cracked it? Obviously I think Boston Dynamics is just legendary in that regard.
Yeah.
Do you have another one where it was like
You mean
IIT?
a good example?
Yeah,
positive
Well,
examples.
I think IIT definitely. IIT was at the DARPA Challenge as well, right?
Yeah,
So
they were there too, and I think they like put together a robot in 1 year, and like they, you know, did decently. So yeah, I think they were a positive example, I would say. Maybe because they were fresh, it was a very young team, so they didn't have any legacy that would slow them down. So maybe that kind of helped them. So yeah, I think that's a good example of like.
At the end of the day, a lot of the time
yeah.
when this gets mentioned, let's say at Imperial, like teams at Imperial, it's more often than not like leadership coming from the professor. Like the professor has to be like it starts from one man or person.
Yeah.
That
He's
really
the one that sets the culture, the communication.
Yes, and without that one person, it just doesn't kick off. And maybe throughout time there are like these like special individuals who have created an atmosphere of just.
Yeah. I mean, the professor or the manager sets the culture of the whole team, right? And then he also, you know, is the one who hires people. So he's the one who, you know, has to also pay attention to the how do you say it? Like the emotional intelligence of the people he hires. Like some people, you know, also consider that aspect, make sure that the people they hire, they are skilled in robotics, but they are also like emotionally intelligent and they can listen and work in a team. Other people instead, they don't care and they just focus on the hard skills, let's say.
I don't have any example of good company just because I don't know enough in companies, but I think like following the agile thing is agile force you to have communication like every day, or like to design new tasks together, and that helps bringing everybody on the same table and discussing and exchanging more ideas. And yeah, I think agile is something you really need to do when you are doing robotics. In research, I think like the professor has a big role, because people doing a PhD, they are just newcomers, like they didn't have any job yet, so they don't really know about management stuff. But if just the professor start to enforce some collaboration between people, that become the culture in the lab. While if the researcher just doesn't care, do his thing on his own, and each student are just trying to work on something but don't really talk to each other, then it's a very different ambience in the team.
That's a good point about agile. I mean, so many gurus out there, right? Like, I don't even know what agile is at this point, because everyone has an opinion on what it is.
Yeah.
But it's a good point. Yeah, it's we need a lot of special people that are really good managers and also roboticists, but then also like new perspectives, new ways of thinking about working together and communicating. That not unique to robotics, but I think robotics definitely suffers because it needs it so much, right? Like robotics needs that way more than others. Like,
Yeah, it needs communication because one person cannot know everything. So yeah, agile is a way to enforce that communication. It's almost a skill that, you know, people should that they should teach at the university, that we should all be aware of. Like I didn't learn about agile until when I moved to the industry, so I never heard about that in my academic career. But I think it would have been useful to, you know, if I had implemented it before. Yeah.
You are listening to the XOR.
Human conversations at the frontier of technology.
This is the XOR.
The XOR.
The XOR. The XOR.
The XOR.
XOR.
have you seen unitary robots, right? Like we're talking about payload. I mean, unitary seems to just achieve these every quarter of a year. They just achieve 10 plus 10 plus 10 plus 10
They have
kilos.
achieved amazing results in such a short lifetime.
Oh, what do you think? Okay, let's say there are the Swiss Animal, right?
Yep.
There are the American Spot. Then there is what else is there?
Yeah,
and there is the
Unitary,
Chinese.
Ghost
Unitary.
Robotics, also American.
I wanted to mention Ghost Robotics separately, but okay,
Yeah.
let's say there is
Yeah, it's
Unitary,
still counted.
Unitary, Alien Go, and
B1. That's the tough one.
what was the latest? I don't know what the
B1.
B1 is the latest. And I mean, what it was crazy payloads. How do you think they achieved that? Apart from, okay, let's say we do understand that, you know, great management is required for great robotics teams to make great robots. But how do you think they do it? Like, what do you think is the secret sauce?
Well, I don't know exactly where the funding comes from, but I think it's quite a big budget they have. So I assume that must have helped. That otherwise I wouldn't explain myself how they developed such good robots that quickly. Like they must have had massive teams of people working 24/7.
I think we also tend to underestimate the Chinese. I think there are very smart people there. And the fact that now everything is built in China, for sure people there have deep knowledge about doing things. Like, because they are now, like, they build so many stuff, they have people knowing exactly how build stuff, how to design the thing. So I think we shouldn't underestimate the Chinese just because they have those two things, the smart people and they are doing things, rather than in Europe you have smart people, but we are not doing that many stuff anymore. So maybe we lose some knowledge. So like I remember seeing something in nuclear where people were saying, oh, in France, it's taking years to build a new nuclear power station just because we lost the knowledge about building this kind of huge building, just because we built them in the 80s, and now that everybody that was working on those projects, they just retired, and we just need to learn again how to do that. So I think, yeah, China have people actively working on building things like this. So good knowledge that they get there.
Yeah, I agree for sure. I mean, okay, the funding. I'm not sure actually how many. I always thought Unitary is a relatively small company. I'm not sure how many people work there. I'm not sure how much funding they have. They just, from the consumer perspective, it's like super impressive what they've been there.
Yeah.
China is, I don't think was ever like a robotics superpower as much as maybe Japan and Korea in my mind, and America. But now I think it's crazy what they're achieving in such a short period of time. Yeah, but I think the access to hardware, that's when you join, let's say, entrepreneur first, there is such, or any entrepreneurial endeavor, the first thing that people tell you is like, please, for the love of God, don't do hardware.
Yeah.
Especially in the last year with shortage, it's next to impossible. Like, and robotics is so reliant on hardware, so it's just become an impasse where only hotspots across the world that have access to chips, have access to motors, magnets. Those are the ones like winning automatically. And if you live on an island somewhere like across the ocean, like getting that stuff to you're never winning. And for the price, it's just only people. I guess it makes sense that China, with its access to hardware, is accelerated, growth.
Yeah, that's true. That's definitely a key factor. Like they literally own the raw material mines in Africa, and that gives them probably cheaper hardware in the end.
In what way could you possibly compete with that audience? Like, how could you? Would it be AI? Basically, it's like, if we can't have the hardware, we just like be better software developers, or wait, I mean, you can't undo hardware, right? Like, you can't. Maybe you could be more control and machine learning heavy, and like have cheap sensors, but like a lot of compute that makes you baseline what they're achieving. But it just, what do you think? How do you think you could compete with someone who has just like so much access to resources and funding? Like, how could you?
I don't think we are trying to compete on that. We are just like Western countries now trying to switch to even more servicing thing. We are not a factory anymore. We are doing services. So we're gonna keep building stuff in China, and we're gonna put our software on their robot. That's probably what we are aiming to. Just maybe even building robots now, it's not the highest level you do. So countries try to go above and just do the software, which is maybe something even more where you can get even more money. Just because you do maybe the software once and then you can deploy it to thousands of robots. The software are still a value, but you can scale it very easily.
Well, I don't think it's really like sustainable, like the idea of like just taking the hardware from other countries and like providing services. I mean, you're still gonna depend on the hardware, right? In the end, like the countries who own the hardware, they actually have the power, I would say. So yeah, I don't think it's a good model if that's what the Western countries are doing. I think we're putting ourselves in a weak position.
Businesses do that too, right? Like, it's businesses also have that. Like, I don't know what the quote was about the iPhone, but it's basically that, where it's like, if you own the hardware, like if you build your own hardware, you control the market.
Then you win.
I would say it wouldn't be far off to say that European robotics is much weaker, I would say, in what it has and what it can do in the future compared to US and China, I'd say.
Yes, I agree. To be strong, you have to own the production, I believe.
Yeah, I was actually a bit shocked that I don't think I heard anything about like chip factoring in Europe. I think like there is a big chip shortage, and I feel like Europe is maybe not trying to use that to build more factory in Europe, and that's probably something that gonna be missing in 10 years, because everything is just TSMC and Samsung. Most of the chips are there, and if there is some issue with China invading Taiwan, that's like half of the production of all the chip that is gone for a few months or something like this. So very dangerous game to not have anything in Europe. I think US is much better. They have Intel and few things, but still, like, I think Intel is trying to now produce with TSMC or Samsung. So yeah, it's difficult because it's really high tech. It's not something easy to reproduce. Like when you build a factory like this, it's billions of
Yeah,
dollars.
the investment is massive.
Crazy. But yeah, maybe on the long term, that's something. Maybe you should create that.
Looking into it. I actually, when I first joined Arrival, I was asking a lot of questions. I was asking the electronics engineers. I was like, wait, so who makes this? And they were like, well, it's Taiwan. And I was like, wait, are you saying there is no like European manufacturers? They were like, yeah, there are like 2. And I was like, no way. So for me, it was like a big shocker when I learned about like how these things are sourced and wafers or whatever. Yeah, it's a big, and it seems to be an impossibility. Like, even if you were to create some sort of production, let's say like something very from technology of the early 90s, let's say like some like 14 nanometer chips, no one would want them because it's so like people are so used to the high end.
Yeah.
Like if you're not producing, Intel Xeon level chips, so like 4 nanometers, that the technology behind that is crazy. I mean, they use
the competition.
They
is
capture
so high,
individual photons like have to hit a certain part of the wafer for like the control conditions of that reaction is just so incredible that it can only be done in one place in the world. And if you were to try to compete, you'd have to start from the beginning, right? You'd have to start from the technologies of the 90s, and no one would want them. No one would really say, this is, oh wow, I'm so happy to have I think it was what was it called? There's like a really famous like chip that's like i8080 or something. Like I don't know. It's like like an ancient chip.
Yeah, nobody would accept it now. Yeah,
but I don't necessarily agree. I think for computer, like the new processor, you need that crazy thing, but still, like what you have in a car probably is just some very old that you can build.
Not in a new car. Like in a new car, you have like multiple GPUs and multiple processing. Like it would probably be a bad example, to be honest, because cars are really a high-tech product now, like a lot of compute.
If you consider all the autonomy,
it would be hard to see. It would be interesting to see what this like really pans out in the future with.
I mean, still, like there are all these advanced applications like cars, yes, but I'm sure there are a lot of like IoT devices that don't really need that advanced level of technology, and that could still probably use the technology we had in the 90s. They would be bigger probably, but that's the whole limitation.
I think the thing that you mentioned about not having the knowledge, like I always think about that, and I think there's a term that I've forgotten now about like generational disappearing of skills. That's so interesting to me in general.
Yeah.
But it would really be a sad moment for us to forget. I mean, we do forget. I mean, we're already so software service based as a like nation and a region that a lot of the basic sciences are not accessible. Like it will take way longer. Like I think the example with France and nuclear reactors, okay. I don't know many other examples of like the entire region like lacking in skill so hard that it's now like financially
that becomes a burden. That becomes no, I also can't think of any other example.
Let's mention something about Ghost Robotics. Having mentioned a lot of your Swiss-based, American-based companies building dog robots, what do you think about the whole Ghost Robotics drama? I feel like the robotics community being so young, we only have very few events happening in general. But if you were,
That's true.
like, I don't know if you, I mean, if you're into politics or even gaming now, there's so much stuff going on. But in robotics, like there is actually, we have drama in robotics too.
Yeah,
all right?
sometimes we do. Yeah.
I
And
didn't hear about that.
well, the Ghost Robotics, just the big. You know about Ghost Robotics?
Yeah.
Well, I think let's flesh it out. Basically, it's a spin-off of Penn State University.
Yeah, UPenn, I think.
UPenn. There is, in general, a rise of a new generation of startups willing to do business with defense, American defense, because I feel like for a long period of time there was a shortage, and now there is such low supply of, everyone wants to work at FANG, which Facebook and Amazon and everyone, that now the skill set of the previous generation of engineers working for defense cannot keep up with they need fresh people to join.
Yeah.
And the demand has grown a lot, and now the money has grown. So like a lot of startups, for example, Anduril is a big example in the US, that the guy who came up with I think Palmer Luckey came up with the Oculus VR headset, sold it to Facebook, worked for Facebook VR, and then started this defense military company. And that was a big thing, that they were, like these young engineers are creating companies to work in defense. It's like a taboo topic. A lot of people are disinterested in working with the military if they're like high tech, but not Ghost Robotics. So Ghost Robotics was that they saw a niche in the market, that Boston Dynamics, having been funded by DARPA, which is a huge organization in the US, giving them a lot of funding, Boston Dynamics, having had a good time with them, being acquired by Google and SoftBank, went to more commercial side of things. And now there is a gap, and Ghost Robotics filled that gap, making military dog robots. That was not received well by the rest of the academic community, right? And I feel like, if I'm not mistaken, it was the founders were like shunned by the academic community, saying that there was like a letter that went out online about people who have worked with them previously saying, we condemn your actions, and we don't want to be associated with you in the future, stuff like that. And for what? Like, I feel like maybe I'm more on the progressive side, and I'm thinking, be a bit hypocritical to say that, even companies like Airbus and a lot of space agencies, even the famous humanoid challenge and the urban challenge in mid 2000s, that was funded by DARPA again, that gave birth to autonomous vehicles as we know today, like autonomous cars. Like that, you can really track it down to that huge competition. That that's where the industry grew, from the seed of that competition. Same happened with the humanoid challenge. That for the first time ever, 20, 30 teams across the world have now like this incredible access to be part of this huge competition with humanoids trying to open doors and climb ladders and stuff like that. To then say that you can't do business with defense, and if you do, you'll be looked down upon, and like it'll have consequences with your career. What do you think about the whole thing? And this has happened, in the past 5 years, maybe?
Yeah, it's still a very hot topic now. It's been like a hot topic since when Boston Dynamics, I think, started, since the very beginning of Boston Dynamics, because like you said, they were funded by the DARPA. So, yeah, I agree with you that there is some hypocrisy in the sense that people condemn this, what Ghost Robotics has done, but then they still take funding from the military.
I mean, even to interrupt you for a second,
Yeah.
like internet is a U.S. military invention from ARPANET. Like you can only go so far in saying that you don't want to deal with the military because you owe them actually quite a lot of innovation.
Yeah, no, I agree with you. I think it's also like a specific feature of the US, the fact that like all the money goes through the defense. So the defense literally like is the equivalent of like the EU Commission in Europe, right? Like the money that universities in Europe they get from the European Commission, that money in the US is instead going through the DARPA, right? Like the American universities, they will get most of the research fundings from the Defense Department. So I think taking money from the defense budget is okay, in my opinion. Another thing is putting literally a rifle on a robot, and because that's something that it's suddenly a very real threat. It can actually trigger real fear into people. So I would distinguish, right, like between like accepting funding from military organizations if they're still applicable to broader applications, and instead literally working on weapons. I would maybe
So you could say like you can definitely draw a line. Like there's a clear distinction.
Yeah, I would try to draw a line. Yes, I wouldn't be so strict and completely rejecting any military funding, but I'll try to be more specific about it. Yeah.
Yeah, I always have a mixed feeling about military. I know that in robotics, and mainly like when you do research, people are very afraid of. A lot of people will refuse just completely to work with any military. I'm more flexible because I see benefit of having robots in the military, like. A quadruped robot, I think it's probably one of the best tools to diffuse a mine somewhere. So if I'm working on a robot that can diffuse mine and save life, I have no issue working for the military. Putting a rifle on a robot, it's a bit of a stretch. I think it's not really efficient. The robot will probably fall if it starts to shoot, just because the recoil is too much. And it's like you can kill the robot with one shot. It's not a strong robot, like a bullet can go through the robot and just break everything.
I remember that now that you mention it, it wasn't just for me, it was the paper that got published, like a joined email that went around about the professor. But what was even more mainstream that I forgot to mention is, there was a picture of the Ghost Robotics robot, and it was a turret mounted on it, and that was like very mainstream. I think a lot of people saw it.
And that was probably
really
like the
struck fear in a lot of people, and it was like a tank with legs, basically. That maybe, I mean, people were saying it's too much. Like that's exactly where you draw the line.
Yeah, I don't know why people would do that. I mean, I see like people that also did similar thing with the Spot robot. Like it was not allowed by Boston Dynamics. Like when you purchase one, you have to sign something that you won't put any weapon on it. And of course, some people did or put some paintball on it.
Really, I didn't know that you had to sign. Like, is that something that you know?
Yeah, it's one of the requirements they enforce.
It's like the Ferrari one. What was the story about Ferrari that you can't change
the color?
Yeah, something like that. Yeah. you're like forever required to like abide by some rules. So it looks
Yeah. Yeah, it was Justin Bieber who repainted this
something
Ferrari,
like that. Yeah, the
I
story
think, and
goes.
then he was banned from buying any other Ferraris.
Yeah, but so basically, I didn't know that was the case with Boston Dynamics robots. That you had to like.
But yeah, I don't think I don't know why they did that on the robot. It was sure that it's gonna be a huge issue, but I mean, you can also put a gun on a car. And
Did you think there was a lot of like it was a marketing ploy in a bit? Like it was like a shock factor or factor that they were like, hey, look at this, put a huge turret on a robot.
I don't know. The thing is that I really think it's not an efficient way to do something. Like, just
See, maybe Mathieu has better ideas.
You've got better weapons.
it's just you can take a wheel robot and put a gun on it, and you are much more stable, and you can have like you can already see like machine guns, like heavy machine guns on 4 wheels, and they
Yeah, but the robot has some what's the term? Not animatronic features, but it looks alive, as we said before. So
Yeah.
right, like now it's a different. Okay, same. A humanoid robot is again piece of metal with motors, right? But people see it as a human. So now, if you put guns in the hands of a humanoid robot, that would completely break the internet. I feel like at that point, it has been done.
That's
I think
true.
there's some videos of those. There's a famous Russian video. I don't know if you've
Yeah.
seen it. Yeah.
What is it? The Boss Town Dynamics? Is not that? No.
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 No, I think it was
That's
Robot
an-
Igor. I think that's what it's called, and it
Robot-
just
oh yeah, I seen it. Yeah. That was cool.
yeah, that's pretty. Yeah,
I
you
have
like
to say
that?
it was cool, but scary. Yeah.
Yeah, the garage door slides open, and you just see a humanoid robot like dual wielding some Desert Eagles or whatever. It's like fire, and it just like does some rounds. Yeah, it's a bit. But also, I mean, I agree. Also, I mean, you could go into. I said we'll talk about Black Mirror, right? Like, I mean,
Yep.
it's not even. It's not hard to see that this is probably not the most efficient way. Like, if you really put your like creative thoughts together, you'd say, well, you know, you put it on the drone, it'd probably be even more like harder to catch, more maneuverable. What do you think of that? Like, just in general, because robotics comes in different shapes, right? You can even do like, okay, you worked with quadrupeds, so I brought up the Ghost Robotics example. But I mean, you can go.
You're asking us like what's the most efficient
Oh,
weapon?
no,
Like,
probably
that's what
not.
you're asking?
It was. Yeah, we could make that also an S tier, like a tier list of just most efficient robot applications of like end of humanity. But maybe it wasn't a question directly. It was just bringing another example that it appeared on one of the episodes of Black Mirror, right? It was like these drones that attach,
was
like killer drones,
really
like they like
realistic.
fly into you and they, I don't know, like make your brain pop. How much
I
of that do you consume in general? Like, how much do you watch Black Mirror yourself?
I
didn't like
watched
it
few
at all.
episodes, but not all of them, just because it's too depressing.
Do you think there's a lot of fear mongering in like the overall mainstream representation of robots, like Terminator, Black Mirror, iRobot? All of those movies are to do with, you know, total apocalypse, total. I mean, very few. I think Chappie, like there's so few robot movies that are like maybe Wall-E and Big Hero. What's it
I
called?
can't remember.
Big
what
Hero.
it was called.
Those are like cute
Those
for
are the
kids.
only few positive examples, let's
yeah.
say, of robots in the cinema industry. Yeah. Well, I think it's, you know, like the directors, the producers, they portray what, you know, the real fears are of.
Really?
of
Do you think so? Because fear mongering really gets you the, you know, tickets, right? Like,
Yeah. Yeah. I mean, I expect they have to come up with something crazy, like something scary, but still not that unfeasible to trigger that like inner fear in you. So I think it's good to think about those edge cases, and I don't think it's a immediate problem that we are gonna have to face now as robotics engineers, but maybe in 50 years or maybe 100 years,
Really?
we will start seeing things that
That's quite reserved. Conservative, right? I would say actually.
even sooner you'd
Yeah.
say. Yeah, maybe.
But I do hold an opinion that like most people immediately have negative associations with, especially humanoid robots. Like they always, with the Tesla bot coming out, being in the news. I mean, that's
Yeah.
all everyone talks about. It's just like world domination immediately, and so it gets a bit. As a robotics engineer, I have my own like my eyes roll further than others.
Yeah.
But why does it have to be that way? I think it's a bit annoying also, because there's so much potential, and there's some like, if I have so much like love towards this area, and then it always gets shit on by the mainstream media, and you're like, come on, like, can we not have like can I show you like the good examples? Or
Yeah, it's like knives, right? Like they I guess they were invented to kill animals, like in the prehistoric period. So yeah, they were born as weapons, but like they can also be used in good ways. And I see robots in the same way. Like it's up to the lawmakers to make sure we only use them in a good way. But yeah, anything pretty much has like a good and a bad application.
I think probably people are afraid of humanoid robot because probably there is a link. Oh, if this machine is like a human, it's as smart as a human or smarter than a human, and probably like it's the fear of not being the top of the pyramid of the living thing on Earth that maybe is trigger a bit. And yeah, feeling like you are not in control of everything anymore.
I think that's a good take. I think that's probably exactly why that like a wheeled box with a rifle attached to it will not. You'll be like, I'm smarter than it. I'm still the apex predator. But when you see like a humanoid, you're like, like okay, this is dangerous now immediately. But it has, it's like when a burger has like the same components separated, it looks healthy, but like once you put it in a burger, it's immediately it's unhealthy. Same thing, like a humanoid and like a UGV, like a normal one of those like military trucks with it's the same. It's like, how much different is that? It's the same motor, same battery, just different configuration, like different topology of the same thing. So how come this gets so much attention, so much disdain from the average citizen?
Yeah, I really think like a robot with wheel, it's a wheeled robot. It's not smart, but when you see a humanoid robot, the first thing you think is, oh, this is smart.
Yeah, I didn't think of that. It's a good way to put it.
Yeah, so basically it's because then you're like, okay, then what can I do more than he can, right? Like probably we always want to, like you said, like feel on top of the whole,
Maybe there's some like subconscious algorithm that as soon as you see something, you're like, I could probably beat it. Like I could probably take it on.
Yeah, exactly. I can
probably take it on.
I'm smarter than that. Yeah.
When you walk down the street and you're just like sizing people up, it's like, I could probably beat this guy up. and then when you see maybe with the robots, there's some subconscious thing. It's like, this is still I can still kick it or something.
Yeah.
Yeah, maybe that's why it triggers like extra things. Like, no, this one's definitely gonna kill me. I didn't think of that. What if there was another uncanny valley? Like, maybe we could be the pioneers of that, right? The fear valley, and it's basically a function of how much you think you can, like, how easily you think you can take it on. And the humanoid robots probably fall within the like some dip where it's like immediately your brain responds like nope,
no,
like
no.
I get
This doesn't scare me at all. Yeah.
If like it was humanoid robot but like had short legs or something, your brain would be like I could
I can beat iCub.
Yeah,
iCub,
because iCub is just a child robot, right? So it's not so scary.
Oh yeah. I love iCub and Pepper. You know, these like cute humanoid robots. You know, have you seen? I don't know if there's like a famous YouTube videos where they're like, how many like 5-year-olds do you think you could fight? Like, you know, have you seen this? Where it's like,
no, I haven't seen it. I want to watch it right now.
Yeah, it'll be like, well, 30, and then people like really go and like start writing it down and be like, well, if I was surrounded, like depending if I was surrounded, and it'll be like big football players, like, oh well, you know, if I could really like spread my arms and like really go for it. But like, what
has anyone actually tried that? Like,
well, they do it. The videos I like to watch is when they put like a professional football player against like a team like of 30.
Oh yeah,
like,
that I've seen. Yeah,
10-year-olds, and they just like completely dominate. Well, I mean, they probably the children, but not fighting. Probably not fighting. But we should do that with robots. Like, how many iCubs do you think you could take on?
Yeah, I mean, personally for me, it's probably like about the manipulation skills. Like if I were to see like a humanoid robot who, you know, can walk around like the city like I do, and then I could see that it can also like grab and manipulate things as well as I do. Yeah, that would probably also scare me. Like, I would be really
I think the
starting to think
parkour,
that...
like Boston Dynamics parkour, really got people excited. Like, for me, for sure, like I've seen bleeding edge research, and even for me, the parkour stuff that I used to see now with Atlas not being like the main selling point, I was like, I cannot do that. I cannot do a backflip.
Exactly.
And this guy can.
And
that was, to me...
That's what impresses you, right? By the way, where are the Boston Dynamics videos that we've always, you know...
It all went downhill with the BTS, you know, the Korean singer thing.
I haven't seen them in a while now. What's going on with that?
When was the parkour video?
That was already maybe 2 years ago?
Come on. Like,
I think it's...
Like 5 years ago, maybe. The first one of just... jumping,
the one jumping on the big boxes, you mean?
The one where like it jumps and then it does a 360 like on the spot and then does a backflip. I think I don't know when that was. We can find out. But a couple of years ago.
Yeah, that's probably a couple of years ago.
But that was fascinating. That's just so fascinating. Like, even, I mean,
it's so frustrating when you are working on humanoid quadruped robots and you are working your ass off on research and you see those videos on your
yeah, like
we can't do even like 30% of what they are doing. So
wasn't Andre saying that I mean, he spent like PhD in Japan, maybe early mid 2000s, working on humanoid robots, and he was 5 years of your life spent making this thing walk. And he is like a very successful published author, right? What was the paper title? Walking Without Thinking About It?
Without Thinking About It.
Yeah, Andre Hurd. Please cite Andre Hurd.
Best title ever.
Dr. Hurd. And he was saying, most of his research was just thwarted by when the robot stands on one leg during a swing phase, it's so heavy that the leg bends. Like the actual mechanical structure bends. So it is like non-linearity just from that. Yeah. And then, you see backflipping Atlas, you'd be just completely...
like you're mind blown.
It's a... What has happened recently, I mean, Boston Dynamics has shifted towards... They realized that bleeding money for the past 30 years. So they're making more down-to-earth industrial automation solutions for less exciting stuff, maybe.
Yeah, I mean, they definitely focused a lot on the products for as long, as far as it regards sport, the quadruped. But, Atlas is still supposed to be the research platform, I think. As far as I know, they're still pushing on that. So, yeah, I am excited to see the next video. Like, I feel like it's been long due. I think they've been working on an electric Atlas, as far as I heard. That's what they're doing.
Oh yeah, that would be absolutely insane, right?
Yeah, probably one current issue with Atlas is because it's hydraulic, so you won't be able to sell it easily just because you need much more maintenance than something electric. So probably if they are making an electric Atlas is to try to sell it somewhere.
From my understanding, it being hydraulic, is it not pneumatic at this point? Is it not gas powered?
No, I think it's oil. It's really high pressures.
But that's what gave it like the high power to do backflips, right? Maybe we'd see a milder version of the electric one, but you don't know. Really excited for the Tesla bot as well. What is that going to look like? Looks very slick, but I mean, obviously with the track record of Tesla projects, it's not.
Yeah, we shouldn't, be too excited.
I already seen something saying, "Oh, the actual prototype won't look at all like the picture."
Oh,
just
no,
because you look at the picture, and just like they took a human and they think they can make a robot exactly the same, but no, it probably will have bulky motors everywhere and.
Probably.
There's a quote about advanced enough technology is indistinguishable from magic. And I mean, for sure, like we were so blessed in our lifetime to see some of those things. I was explaining to someone that did not have an engineering background, all the advances that DeepMind has made, and I had a good memory of like the timeline, and I was like back to back explaining the timeline of like DeepMind is only 10 years old. Like it's 2011 maybe. Then they got bought like 2 years into it by Apple, and since then I was like on my fingers like saying, okay, they did this, then they did a couple of games that they won, then they did StarCraft, then they did World Dota, then they won this, and then they started and now we're at the point where they're solving protein folding, weather, ancient languages. They're going into nuclear fission. I think they're like trying to solve
fission,
some. And I was like, wow, like even to me, when I've described the entire thing, I was like, oh my god, like actually crazy.
It's actually
I think
crazy.
Okay, both of them are Google funded, both Boston Dynamics and DeepMind, but crazy, like the advancement has been like logarithmic. It's so like within 10 years they did that, right?
Yeah.
And what's the next thing going to be like? What's the next thing going to be like for Boston Dynamics? Like, let's say they did funnel all that money back like into Atlas. Like, what could be possible? This is such a scary thought.
But I think it depends a lot on the domain. The thing is, DeepMind is doing machine learning, and machine learning is at the stage where it's growing like the Moore's law. I think like things double every 6 months or a year, something like this. They are in this phase where it's still growing, but then after some time you have like a step and it's kind of stabilized. It becomes very hard to get new things. So like probably hardware, you still have something, but it's become more and more.
Do you think they've plateaued? Do you think we're at the plateau, starting to plateau at the hardware level? And like, maybe we'll see like, okay, 10 years of research with DeepMind, we'll start seeing like, okay, this like how many games of Go can you win? And maybe it won't be as impressive. or what?
Yeah, I think at some point we will probably reach a plateau also in machine learning.
What will be the limiting factor then? Like, does it boil down to the hardware, to the compute power? Like, are they growing so fast because the compute power can keep up with?
Well, it
what
also
they
could
need?
be. I was also describing that, when they trained, I think it cost somewhere around 20 million to train just the electricity bill for the training of the Dota 2 at one iteration was 20 mil. And they have football pitches size like computers, like server rooms, and they have specialized hardware to do that. It's not just like your average computer,
of
it's
course.
compute units that are built for this. Maybe with the energy crisis that we will have, it will just be like financially impossible to train these
it won't be
models.
feasible anymore. Won't be sustainable, not even for Google.
Yeah, wow.
Maybe, yeah. It seems impossible, but maybe.
You are listening to the XOR.
Human conversations at the frontier of technology.
This is the XOR.
The XOR.
The XOR. The XOR.
The XOR.
XOR.
Let me ask you another question. I feel like, another one of the staples of the show is at the end, I like to remind people about an interview question that I had that was amazing. And it was, I don't know if you watched the previous podcast, and it was something along the lines of, the interview question was, in your field of your choice, like whatever, it'd be the one you're applying for, what's the recent greatest thing that blew your mind? And you can't mention what's on the news right now. So back then, the interview question was, it's like, you can't mention the rocket landing of SpaceX, because that's exactly when it happened around the area. It's like, what's the craziest thing that you thought, no way this is possible? And I've had some good answers before, so you guys are on a high... So in robotics...
So, like something that I thought it was never going to happen, and yet it happened? Yeah, that's what you're asking?
Right now.
Yeah.
Like right now, what do you think is the greatest achievement that you just... It's crazy to believe.
That we witnessed, that has happened already.
Or you've seen, that you know of in your field. It's just like, that's crazy. Let's say previous podcast, Joseph talked about the James Webb Telescope.
Right.
He's into space and physics.
Yeah.
That to him was just
Mind-blowing.
blew his mind. And that's happening now. So with that in mind, can you come up with something that...
I think for me it's the recent progress in AI, like the transformers, the AI art and things like this. That's really, for me, change thing, because you see that, oh, fuck, it's something you think, oh, it's gonna be there in 10, 20 years. And then no, it's coming. And like every year they make something better, they double the size of the network, and it's getting better and better. So like it's something you really see that it's coming, and it's coming really, really fast. So yeah, that's something that very...
I mean, you've mentioned Stable Diffusion and DALL-E, and I think there's one more that I'm missing. That's Midjourney. Like I follow a lot of artists in general, like that are not AI artists, but all of them just spamming those AI generated art. Like I've tried it, and also recently that when I had a startup idea, I was, in the beginning you want to generate some art, maybe get some concept artists to draw it for you, and I was like, I don't have money for that. Let me go in Midjourney, and like I actually got some really good results. There was like typing it in, and for me that was like, I can do this. Like I can actually show this to someone and say, here's my concept. Have you had something like that with you were saying you were playing with Stable Diffusion? Did you generate something that you were like, wow? What was your inputs?
I was mainly like the thing I can see is like I used to play like figurine game, war games, or role playing games, thing like this, where you always use your mind and you don't show really picture or thing just because if you can't draw something, there is no point. But now you can easily make your own game, like instead of having just you can make your own game with nice illustration and things like this. So I was actually like playing with draw a dwarf women and something like this.
Right,
or,
like DoD.
no,
right?
Yeah, exactly.
Yeah, because a lot of that is based on narration and imagination, right? And you have to have a good dungeon master that is really good at
Yeah, but like
describing
if you
it.
want to create a board game, sometimes you don't want just you want to have nice picture somehow somewhere for the board game, and let me see if I can find the.
I think it's a good response. I think, yeah, definitely everyone's been touched by it. Everyone's seen it. And a lot of people outside of the AI sphere, because I think the user interface has become quite easy and it's natural language based. So a lot of people just open the website, type it in. A lot of people who have never touched AI can now do so, and they have experience. And a lot of people started, like, they'll do one thing, two things, and then they're hooked, and they actually like you can see the snowball. Stop. It doesn't stop at just one, like a chatbot that just like it's okay, and you ask a couple of questions, and that was fun. A lot of people are getting really involved in the AI art, and they see applications, and it's for sure.
It's an avalanche of applications.
Yeah, like, and people from all spheres who are not interested in art or whatever. It's even the previous barbecue that we were at, there were people that like pulled out their phone and was like, oh, this was my input. Okay, right. You're generating some orcs in wearing armor. That's pretty good. Okay.
Yeah, I have to say that I was also really impressed by like
you can't
the
use
amount
that.
of people.
Come on, you can't use that. You have
no,
okay.
I'm not using it, but it is astonishing like how many people use it. Like I've seen it. It's really cool. I mean, like you said, like random people will tell you, yeah, I've also tried it and I love it. Like, so it's really crazy. Well, I mean, I can't really think of like a good answer, like as regards technology. I mean, the only thing I can think of, it's not related to technology. It's more about like the whole, it's more about the whole situation with the climate change. Like, I feel like in terms of like sustainability of the energy, like we were discussing before, like I feel like finally now the world has understood like how urgent it is to change. It's something that a few years back it seemed so far, it seemed impossible, and now because of COVID and war, like politicians have finally understood like how important it is to change. So not sure it answers your question, but like it's just what I thought of like when you say something that is happening right now that I didn't think it was possible, that it could happen that quickly, and yet it did. So yeah, I mean, it's not over, it's just the beginning, but at least I can see like the politicians acknowledging the challenge.
That's a good answer. No, it's even a better answer, because you're basically saying the population's attitude towards climate and needing to do something has very quickly shifted.
I mean, when was Greta Thunberg like starting her fight? When did she start, her own strikes? That was just a few years ago, right? And she was completely alone. She was fighting for, Well, she wasn't alone, but there wasn't any.
I've definitely seen a lot of. I mean, being part of the EF cohort. I mean, a lot of young people, spoken to a friend just yesterday, the robotics engineer, like very interested in doing climate change startups.
Yep.
That is maybe not the hottest thing before. Like a lot of people are super interested in having climate impact and doing better for the climate.
Yeah, exactly. That's something I find amazing. I'm so happy that it happened so quickly. I'm not happy that it for the way it happened, because like we had to get there because of all the bad, the war and COVID. But that's one positive one positive side, I would say. I think like probably like most of the CEOs of like any companies in the world now accept that their main challenge now is to make their business sustainable. So
you know what I was thinking the other day that I think is so underrated? The ocean cleanup project. There was this young guy with long hair and a weird name.
Yeah, I don't know his name.
I think he's Bulgarian or something. He is, and I was like that challenge. And then I think they had some milestone that they've achieved. They've cleaned out like, I don't know, some gigaton of rubbish from the ocean. And I was like, that is to me super impressive. Like that guy was alone for sure. Like he was obviously. I mean, he has had millions in funding from charities, from crowdsourcing, but he's gone far in the past 10 years. Like just from prototypes, from like just trials, from very manual labor. Now they're doing it such a big scale that it's just so impressive. Like
they got traction. All these similar projects, they got a lot more traction than they used to, right? So we have to hope it continues this way.
That's a very powerful note. I think we'll end it there. I think it's been amazing. Thank you guys a lot. Let's do a triple.
Thank you for having us. Yeah.
Trifecta. And that's it. That's XOR 0007. Thank you guys.